Buongiorno, vorrei cogliere l'occasione per darvi benvenuto in questo panello intitolato Calcolo quantistico per lo spazio. Mi chiamo Roberto Mazzolin e ricopro il ruolo di capo strategia della difesa, sicurezza e tecnologia del gruppo REA, una società multinazionale di ingegneria al servizio degli interessi istituzionali presente qui in Italia. Oggi abbiamo un prestigioso panel di esperti italiani e internazionali che forniranno il loro pensiero su questo importante tema. Quantum computing is one of the most rapidly developing emerging technologies. As often as every few weeks, announcements of new discoveries and their commercial applications become apparent. With quantum technologies, concepts that even months ago may have seemed impossible are becoming a reality. New quantum sensing technologies shed more clarity into the world around us. Quantum memory allows us to store and synchronize quantum particles for improved secure communication, and quantum computers will enable us to tackle problems our current computers cannot solve. With all these positive attributes, there's a darker side of quantum computing that's being understood more as well. With new technology comes new threats. Brute force attacks, which require very powerful machines like supercomputers or GPU farms, have not been feasible until recently. With the development of quantum computers, brute force attacks have become much less challenging to those who have the technology. The industry is responding with answers on how to deal with bad actors trying to break cryptography. There are efforts by NIST and ISO organizations to test and standardize post-quantum cryptography, mathematically designed to make quantum computers no better at breaking this new generation of cryptographic algorithms than classical machines. There are also devices in the market focused on quantum key distribution. Naturally, it isn't easy to understand what differences there are between the encryption technologies, moreover, determine which ones are better. When it comes to technology, it's critical to understand its uses and correct applications. Just because something fits into a category, cryptography in this case, it's still essential to know where and how to apply it in real life. Although QKD is a big concept in quantum computing, it hasn't been popular recently in the press because QKD is still developing. It's incredibly misunderstood. Ultimately, quantum has both good and bad attributes. However, the development of this technology will change the scope of cybersecurity forever. Today, we're fortunate to have an extremely distinguished panel of participants who will help us unravel these concepts and lend greater clarity as to the applicability of these technologies to the security of our society, as well as help us afford a practical vision of how within Italy, and even more broadly, translate theory into practical initiatives that will ultimately ensure the security of our society and associated public and private institutions. The panelists have been prepped to offer their views on themes relating to the nature of the impact that quantum will have on key systems supporting societal resiliency and its impact on citizens. As well, given that much of the current focus is on research and development in this field, will pursue their thoughts in regards to a vision for next steps to translate the current R&D activities into practical capabilities that will protect broader institutional and societal systems underpinning our way of life. I'd like to take a moment and introduce our panelists. Today we have Nicholas Ramponi, who serves as a Senior Project Delivery Manager for the REA Group. He spent most of his career in the space industry working for leading satellite operators in governmental and institutional markets, managing complex system integration projects to deliver on initiatives such as the quantum communication infrastructure, navigation, defense and security, and humanitarian and disaster response. He's also the program manager of the REA end-to-end international use case operational QKD application and services project. Next, we have Tommaso Occhipinti, who's the CEO of QTI Quantum Telecommunications Italy. He started his career in 2002 in the academic research field of quantum astronomy and quantum communications at the University of Padova. In the following years, he started his business career founding innovative startups, and he was among the QTI co-founders. He's been instrumental in the development of the international market, collaborating with business developers such as TIM, Telsey, and Sparkle companies. We have remotely connected today Davide Calonico, who's the head of the Quantum Metrology Division at the Istituto Istituto Nazionale di Ricerca Meteorologica in Torino. He works in primary metrology, atomic clocks, quantum technologies, and digital innovation, and has realized the Italian quantum backbone devoted to research and development in quantum. Since 2019, he has been the Italian delegate to the European Quantum Communication Infrastructure Initiative of the European Commission, and he's widely published, coordinating a variety of projects sponsored by Italian institutions, the European Commission, and private companies. Next, we have Professor Michele Mosca, who is the CEO of Evolution Q, and he's also currently a full professor in the Faculty of Mathematics at the University of Waterloo in Canada. Dr. Mosca has made major contributions to the theory and practice of quantum information processing, particularly in the areas of quantum algorithms, techniques for studying the limitations of quantum computers, quantum self-testing, and private quantum channels. His current research interests include quantum computation, cryptographic tools designed to be safe against quantum technologies, and software tools for quantum information processing systems. He's the founder of the ETSI IQC workshop series in quantum safe cryptography, which brings together a broad range of stakeholders working toward globally standardized quantum safe cryptography. Next, we have Giancarlo Varicalli, who is the head of telecommunications and navigation department at the Agenzia Spaziale Italiana. Signor Varicalli is an electronic engineer with 25 years of experience in the space sector. He joined ASI in 2005 after working in the main Italian aerospace industry on SATCOM development programs. At ASI, he's led several space projects in the field of telecommunication, navigation, and Earth observation, among which were the development of the second generation of Cosmos SkyMed satellites equipped with synthetic aperture radar. Last but not least, we have Antonio Sturiale, who's the Director of Domain Telecommunications for Italy at Thales Alenia Space. Having joined the company in 1992, he's been responsible for a wide range of activities, including commercial, institutional, and military communication satellites and payloads. He's also been responsible for optical and quantum QKD programs, including involvement in SAGA, AB1, Hydron, and other Italian QKD initiatives. He's also responsible for future constellations and secure communications and systems for exploration and colonization for the Moon and Mars. And he's had a wide range of previous leadership experience in the areas of space engineering. So with that, please join me in welcoming our panelists today. So we'll get to the point. What I've asked each of the panelists is to provide us with about 5 minutes of their views in terms of the societal relevance, the importance of quantum, its impact in society, and the views on how to go about. So if we may, I'd like to start with Giancarlo. Please, could you please take us through your thoughts?
Hello, everyone. Thanks to be here. I think you already framed well the issue of quantum. We are in a situation where quantum computing is developing, and probably we will witness a full-scale development in the next years. Which is really a revolution in the sector of computing. But this brings other issues. First of all, the issue of networking. When we have computers, we need to network these computers. So we need technology, infrastructure to distribute this computing capacity. That brings the need to develop quantum networks, and also in parallel to revise all the cryptography, the security issues that come along with this. Quantum key distribution is a first I would say, technology born aiming at counteracting the potential threat of using quantum computing to decode, to hack the communication which are today secure but with the computing processing will not be anymore. QKD is, as I said, the first attempt, but it's just the first step. Just a first step and just a first solution to this. Other solution can be the so-called post-quantum encryption, post-quantum technologies based on software algorithms. But we don't have today the clear view of what will be the exact, the best solution. So we are investing at national level, at European level in the QKD as a possible means to counteract possible threats to the secure communication by quantum computing. The final word on this will be said in some years, but we need to invest in these technologies, to invest in untrusted nodes, which are the best solution to guarantee the security everywhere, both on terrestrial lines and on space. And for this, we need also new technologies like memories, quantum repeaters.
Thank you very much. So, very clear articulation of a methodical approach from a strategy perspective in terms of a Italian national investment from an ASI perspective. Thank you. Next, could I call on Nicholas, please, for your thoughts?
Well, hello everybody. So on our side, we've started a project which is called INT-EU QKD. So typically looking at quantum in general, QKD, but from the end user point of view. So the idea of this project is to look at how quantum can help end user today to solve the quantum threat when quantum computers will be available. And in our point of view, when in our digital economy, you need a global solution. So in our consortium, we have a partner, EvolutionQ from Michele Mosca, based in Canada. We also have another partner in Singapore, bringing the space segment. And what we want to do is to deploy operational testbed to validate system design and solution using quantum in order to provide an end-to-end secure solution. So our idea, again, and I insist a lot on that, is not to do research and development. There are experts already focusing on that, but looking at how end user, how we can bring solution to end user. If you are a bank and you want to secure your communication against the future quantum threat, how can you do that? If you are in the healthcare domain, how can you do that? One of our partner based in Luxembourg is Post Luxembourg. The advantage of Post is that they are a national telecom operator, but they also have a bank. So typically they will be able to test what we will be implementing with their own bank, own telecom solutions. So the project itself is really to deploy an operational testbed, to build an hybrid network, so to have a terrestrial network first, and this solution is already deployed cross-border between Luxembourg and Belgium, and then to bring the space segment with a spectral satellite to be launched next year, and to see how a terrestrial solution can cope with a space solution using QKD. So that's one part of the hybrid model we have in mind. The other part of the hybrid model is we want to provide an end-to-end secure solution. So ideally, up to my mobile phone when I'm connecting to my bank account, how do I do that? And most probably the solution to that is not only QKD, but it's a combination of QKD and PQC, which is the other part of the hybrid network. So for us, this demonstration, this operational testbed, will help us to test interoperability between a terrestrial and space network, between multiple vendors of QKD equipment, and also between QKD and PQC. And this is what we're looking at. We started the project a year ago, and the plan to get the operational testbed is within the complete testbed is within the next 2 years, knowing that the terrestrial network is already deployed. So this is what we want to look at with the INT UQKD project.
Thank you very much for that. A great example of a public-private partnership that's serving as a catalyst for broader development within Europe. Thank you. Next, turn to Dr. Mosca, who's been a key driver internationally in this environment. Grateful for your thoughts.
Grazie, Roberto. It's a pleasure to be here with you all. I hope you can hear me with all the background noise. So, as has already been mentioned, quantum technology has evolved in the last few decades from a speculative idea driven by some visionary academics to a suite of technologies, to actually a whole technological ecosystem of companies ready to work with the end users to translate the opportunity into value for society. So the big question is, are we going to do that, or are we just going to keep doing theater, innovation theater we call it? And that's a choice. Like, we can go either way, but companies that choose actual innovation and its adoption, countries that choose it, societies that choose it, will be better off in the long run, and will be really the global leaders in the long run. So we know quantum has this unprecedented power, for example, because it'll break the cryptography that is securing our current economy. One thing that should show us is there be a wake-up call. The real question is, wait a minute, you're saying one new algorithm could basically take down the global economy? How is that possible? It happened very slowly, because when we first deployed the internet, it was just a curiosity for academics. Then we thought, oh, this could be useful, so we started using it for more important things, and then more important things. And then we started saying, oh, we need to secure this against some immediate attacks, right? But then are we securing it against future attacks? Not really. And so we need security by design, but we're failing. In fact, we need more than security by design, because the new codes could also be broken. We really need resilience by design, right? And now what about satellites and the space economy? Again, we've been using them more and more. We're going to create even more dependence. We're creating a whole new economy. Are we going to make it secure? And very importantly, are we going to make it resilient? That's a choice. Like the previous panelist said, you can't fix the leaky roof when it's in the middle of, when you're in a thunderstorm. And we're really facing not just an isolated random thunderstorm. Here there's adversaries, right? It's not a weather event in space, which absolutely we need to be more ready for. Here there's actual adversaries who are proactively controlling these attacks. So we absolutely must be more resilient. Now, quantum can be part of the solution. It offers us new encryption methods that can't be unexpectedly broken by a smart mathematician anywhere in the world, right? So it's a wonderful new cryptographic system in parallel to the current ones and the algorithmic ones that we have and should continue to have, because 0 layers of defense is not secure. 1 layer of defense is secure but not resilient. So we need the 2 layers of defense. And quantum cryptography can be the driver alongside other symmetric key methods for that 2nd layer of defense, right? But we have to choose to do that. And the space economy can be an enabler, of this new generation of cryptographic tools. And of course, we can use quantum cryptography to protect the space economy itself. So we're at a very exciting time, and I think we have a really wonderful opportunity to work together to make, again, to protect, the space economy and to use it as an enabler to protect the whole economy.
No, thank you very much there, Dr. Mosca. That a great characterization of the increasing relevance of quantum, but also the context within which, in terms of being able to establish a bit of a view in terms of how we migrate from the current environment into a futuristic one that maintains resiliency of our critical infrastructure. Thank you very much. Dr. Rocchi-Pinti, please. You've been involved in some very, very practical industrial engagements.
I use this one. Thanks, the organizer. Thanks, the organizer of this event. I really would like to introduce me better and the company that I represent. I am one of the founders and the CEO of QTI. QTI stands for Quantum Telecommunications Italy. So saying that we think that QKD, I mean the topic of this panel, or I mean the quantum technology, must be a telecommunication topic. So we are deeply connected. I mean our DNA is telecommunication engineering, and in fact our main shareholder is Telecom Italia, so TIM, in particular Telsi, which is a very historical company in Italy dealing with hardware ciphers for defense, for the government. Okay, so you understand why they invested into our company to spread the use of QKD into Italy and in the international market. So this is the initial presentation. What I would like to say to this audience is that there's a little bit of difference between what is QKD at the moment, right now, on Earth, on the fibers, on the optical fibers, and what is QKD on space. So as a company, as I told you, we are historically connected to the fibers, to the optical fibers, so we are, I mean, the player for QKD on Earth, and we have products. We have QKD apparatuses, so generators of quantum keys for higher level application, for deciphering machines and for applications. So they are essentially rack-based machines that you place, you plug into your racks. We have also the upper layers for managing the keys. So whenever you create keys among a complex network, among a mesh network, you need a governor of the distribution of these keys among the application layers. So we have the so-called key ME, the key management entity, and we are making very interesting collaboration, for example, with Evolution Q or other important players in the market in order to integrate and to make this working better. What I would like to say is that, so we are essentially shipping to the customer. We have customer in Italy, we have customer international. What we don't have is the customer in the space right now. So space is a little bit, of course, making right now the overall economy of QKD. So we want to be there, and we are very interested to make something for this economy. And there's plenty of space for many players. Just to give you some hints, we are very interested into the optimization of QKD algorithms. No, I'm not speaking about the key management, but just the optimization of the QKD algorithms to increase the key rate. We are working on on different research programs in Europe, working on PIC, so on photonic integrated circuits, in order to make QKD small, light, and very efficient just to flight into the satellites. So there are many things, and we think that we are a good player to work in this economy. Thank you.
Yeah, thank you very much. Very interesting insights in terms of a market evolution and how a company can play a key role in terms of serving as a catalyst in developing that environment and engaging and integrating in existing critical infrastructure. Thank you. Dr. Sturiale.
Good morning, and thank you for the organization of this panel. I want to start from what Professor Mosca said about the choice. Yes, we are really in front of a choice today for the space. And here, I bring my point of view as a large system integrator for space application. And my personal view is that today there is the maximum amount of opportunity that are rising by the application of quantum communication in space. It's not only quantum key, but all the things that are related to the secure communication, the quantum communication, because we will see in the next few years not only the famous breaking point for when the quantum computer will be able to break any security algorithms that today is on the market, but also we will see the increase of the needs of quantum communication, because there will be a big amount of data that has to be exchanged between those computers. We will start with the quantum key, of course, because it's the most today is the most mature, even if it's still in a middle stage. But we have to think to how many opportunities has today the industries and the countries themselves in growing in the quantum communication. Today we can choose to stay and follow as a country. I'm talking for Italy, because we have a lot of small and medium enterprise. We have a university that are working on this topic. We have to federate, to integrate, to avoid that our competencies will be spread among different countries, different systems, just as a cherry picking of building blocks. And this can be done with national projects that could be raised and driven also by the agency in this case. And the agency is very active today, since some years on the topic. There are optical roadmaps, quantum demonstrators that are ongoing. So these are the opportunities that we can get to move from mathematicians and engineers to also physics that can be able to support this transition towards the quantum communication. There will be a transition phase, of course. A lot of people is talking about post-quantum, that is enough. There is no need for proceed on the quantum key, but we are still in the sovereignty of mathematicians. We have to move to physics, to the physics point of view, to understand that what is telling by who is managing algorithms and talks about post-quantum is true with respect to what we can do with quantum communication. So the opportunities for the application, of course, many fields, not only military. We are thinking to embassy, to the bank system, but to each single of us that will have to make a transition with with his phone paying on PayPal system or whatever in all the parts of the country. So it's something that will go through the whole system. We need to work with the young people. I saw around a lot of young people that today is most of them are not focused on building something in a middle or long term. They are thinking in a 2 years view. So we need to be sure that their view will support our intention and our view to grow in the quantum communication. We need most of them to work with us. So opportunity for young people, for small, medium enterprise. We have a lot of representatives. We work with many of them, but we are still at the beginning, and we need to federate the capability that are today recognized for Italy in the sensors. In the algorithms on ground, there are already mature products. We have just to bring them to the space as a first step of the future growth of quantum communication.
Some very interesting comments in terms of how an industry base can cultivate a national ecosystem, writ large, to be able to develop an indigenous national capability that can be used internationally. So very interesting insights. Lastly, but not least, we have Dr. Calonico. I believe we have him connected. Davide, can you hear us? Are you connected? Thank you very much for joining us. I believe you've been tracking the discussion.
Thank you.
Please go ahead. Interested in hearing your view. You're really at the pointy edge of the Italian national system development in terms of the background. So we're keen to hear your thoughts.
Okay, so I think that we are looking at a huge transformation. And I think that what I would like to emphasize, rather than the scientific and technological content, is the method. So the method that we are pursuing in this quantum transformation is in particular in Europe is also the effort to put together academia, industry and society right from the start. And this is a huge effort with a big impact, and it's not easy, of course. What are the consequences? For example, we are often told that this technology has some challenging points to be fixed, or can be more mature than today. Yes, it's true, but we have a lot of working points and things that are now working, products that you can buy, but you have this opportunity and responsibility
Hopefully this is not a cyber attack that the quantum cryptography could defend.
What we are...
Yeah, are we
can
back
you hear
on?
me? Yes. What we are really requested is to do this work in close cooperation also with society. So looking for the impact on society of this kind of structure.
Okay. No, thank you very much. Thank you very much for this. So we've got a number of minutes left, and what I'd like to do actually is perhaps pose one question to the panelists. Again, just to go in turn, a bit of a lightning round, if you will, of key points. So the context is that when we see now we're in a phase of there's increasing public dependency on space capabilities to deliver fundamental services and critical infrastructures that underpin our societal resiliency and government legitimacy. And so a lot of these systems now are protected by traditional cryptographic means that when we look at the threat of quantum capabilities of being able to capture existing data for subsequent decryption pose obvious threats. We looked at this in the context of for example, the Chinese Belt and Road Initiative, and they're moving very quickly in terms of developing practical systems. So the race is virtually on. When we start looking at this from a Western perspective, what I would like to ask each one of you is, what would you see as being the key principles that we should be adopting when we're looking at taking what's currently in the West as being a lot of independent research and development activities that are doing interesting things, and being able to coalesce them into a functional capability that supports not only Italian interests, but broader Western interests. Maybe if you can take a minute quickly to kind of give us your key principles that you see as relevant. Signor Varacalli.
Well, I can tell you what is going on in Europe, where we are much more focused. In Europe, there's an initiative born some years ago called EuroQCI, aiming at developing a European-wide network of secure communication based on quantum cryptography, quantum key distribution. This is done through the separate developments of space segment and the terrestrial segment, because terrestrial are in the hands of the single nations. The key element in this case is to guarantee a cross-border interoperability, because every nation has the responsibility to develop a national network in fiber optic. But the key element is the interoperability across the borders. On the other hand, we have a space segment which has to be, of course, a single space segment, able to connect the single local areas and remote areas together. Also, the key element in this case is the cooperation among the several nations, because every nation has its own capabilities, technological capabilities, but the key element will be the bringing together all these capabilities and build up this infrastructure. Of course, Italy has a strong ambition in this case because of the technological capabilities and the investment that are in place, also through the European Space Agency with the SAGA project.
Okay, thank you very much. Nicholas.
Well, for me, one important point, and I already mentioned it before, is the interoperability. Interoperability between multiple vendors, multiple technologies, and for this interoperability, there is something key, which is standardization. We need to have standards which allows different systems to be interoperable. That's one element, and in our project, we've already seen that even when you have an existing standard and you plug two equipment, it not always works because you have the interpretation of the standards. But having standards will also have another impact, which is you will have multiple equipment, there will be a bit more competition, and the cost will go down. If I look at the space segment has a high cost, and one of the elements of the cost is the optical ground station. If there would be standards allowing one ground station to be capable of receiving different space segments, then you increase the usage of your ground station, and you reduce the cost rather than duplicating the number of receiving equipment for the dedicated space segment. So for me, the two elements are standardization to drive costs down.
Yeah, thank you. Very practical approach. Dr. Mosca.
So this great opportunity we have was created by sort of undirected research and just creation of opportunities. But to really benefit from it, we need to transition to some very focused, audacious, mission-oriented projects and programs, right? So to really seize the quantum opportunity, it's really a matter of using it or losing it. In the context of global competition, if we don't use it and we don't start using it soon, we're going to lose that opportunity. And what these missions and opportunities, I think, consist of is trusted, countries and companies and so on working together to build a bigger, better pie faster, and then sharing in all the wealth and prosperity that we can create together. Meeting challenges like interoperability and so on. So I think that's what we really need to do and focus on very rapidly, and recognizing this will be for the greater good of all our societies.
Well, thank you very much. Again, theme, mission-oriented projects are like that. Dr. Occhipinti.
So I totally agree with my colleagues here in the panel, so I don't want to add so much on that. I would like to come back to the technology, as I am also an engineer. The point is that someone spoke about PQC, post-quantum algorithms, post-quantum communication, as a sort of enemy of quantum key distribution. This is not. So QKD and PQC can work together. And maybe I explain better. To answer your question, the research group, the entities, the governments can collaborate also on these kind of topics, in the sense that in some cases you use PQC, in some cases you use QKD, depending on the level of the security that you need. But there's also another point. I'm sorry, the time is finished, but just to say the last sentence, us, for example, in Quantum Telecommunication Italy, we are using PQC algorithms to make, for example, authentication between the parties, between the machines. So just to say, to give a clue that the technologies are interconnected. And so we can work together with other groups to do this.
Okay, thank you. We started a little bit late, so I'm going to exercise a moderator's privilege here. So I'd like to at least permit Antonio and Dr. Colonico, quick 1 minute burst from each one of you on your thoughts. Thank
I will
you.
be very, very quick and fast. Just to add the importance, in other words, on the importance of the federation and the fact that we can build some infrastructure that will be spread across the countries in Europe. Without this infrastructure, that is the key point, the risk is that any experiment, demonstrator or proof of concept will be switched off in 2 years because technologies are very fast, evolution is very fast, and there will be something new in 5 years from now. So we need to cope with an infrastructure that has to grow in a federated manner. And here the standards that our colleagues was putting on the table as a key element are really important. Okay.
Super.
Thank you.
Thank you. Dr. Colonico, if we could trouble you for a minute burst.
First, as the coordinator of EuroQCI in Italy, I would say that the ecosystem is really important to put together again the industries to produce and to test for a real uptake of users and stakeholders. This has to be done at the national level and federated at the European level, for example. And of course, the terrestrial layer and the space layer should talk together right by design from the start, as we are doing. And second, standardization is crucial, and I have to add also certification. So we need really to have third parties, neutral third parties that can assess that our quantum devices are working properly, and operability is also granted by design, but also by a certification and standardization authority or a structured service in that sense. And so also metrology is really important in this development. Thank you.
Thank you very much. We could spend all day on this. Ora, è stata un'ora passata molto istruttiva su un argomento affascinante e progressista. Giunti ormai al termine, vorrei cogliere l'occasione per ringraziare il pubblico per la cortese attenzione. Sono sicuro che sarei d'accordo con me sul fatto che i nostri illustri relatori ci hanno fornito un'opportunità rara e unica per ottenere preziose informazioni su questa tecnologia in rapida evoluzione. Inoltre vorrei esprimervi i miei migliori auguri per il resto della giornata, buon viaggio verso casa e felicità durante questo periodo natalizio. A tal fine potresti unirti a me nel ringraziare il nostro pannello. Grazie. Thank you very much.